In our previous video, we explored logistic regression using family income level as an ordinal independent variable. Now we're going to expand our model by adding a second independent variable, gender. But unlike income, gender is nominal, which means its categories don't have any inherent order to them. So this will change how we interpret the effect on the degree attainment. So if you haven't watched the previous video, you might want to, because we're building on what we did in the last one. We're using the Beginning Postsecondary Students 2012-2017 dataset, and we're going to do the logistics regression here. So choose logistics regression. And we saved variables last time that we want to use our saved variables. Family income level, we created levels from the continuous variable, and we want that to be one of the independent variables. And we'll choose poverty level as our reference. Dependent variable, remember, has to be binary. So we combined where they got their degree and called it degree versus no degree. We're going to use degree as our reference. And now we want to add gender to the independent variable. So go back to show all variables. And gender is a student characteristic. So it's down in the S's, student characteristics, gender. And we need a reference level, and we're just going to choose male. Doesn't matter what you choose, but that will determine how you interpret your results. And now run, and we'll take the suggested weights. The intercept odds ratio is 0.299. This tells us the baseline odds of earning a degree for the reference group, which is males in the poverty level income category. That means for this group, the odds of earning a degree are 29.9% as likely as the odds of not earning a degree, or far less likely than the odds of earning a degree. So in this logistic regression model, we're interpreting the main effects of family income and gender. The main effects describe the independent contribution of each variable to the outcome, in this case, degree attainment, while holding the other variable constant. So it's going to compare the different income levels to the poverty income level, regardless of gender, and then it does the gender comparison, comparing females to males, regardless of the income. You can pause this and read how to interpret the odds ratios for the income levels. And you may have noticed that the odds ratios for the income levels are slightly different than when we did not have gender in the model. And that's because the model is more complicated with gender in it. And the variance, some of the variance that previously was attributed to income can be assigned to gender. And they're not very different, but they're just slightly different. You may have noticed that. And here is the interpretation for the odds ratio for gender. This is comparing females to the reference group males. Now we're going to add an interaction term between income level and gender. The interaction term is going to allow us to test whether the relationship between one of the variables, like family income, and degree attainment depends on the level of the other variable, like gender. And when we create this interaction term, the order of the variables doesn't matter. So let's see, interaction term. We're going to add an interaction term, gender, and income level. If we had a lot of variables, which you can do, you can look at the interaction between any combination of them. So here we're going to select these two and add the interaction. And like I said, it wouldn't matter what order you selected them in, same results. So save that interaction term and then run it. When we added the interaction term between income and gender, the interpretation of the main effects for the income levels changed. Previously, the main effect for income represented the independent effect of income on degree attainment, regardless of gender. But now, the main effect for income levels, like the odds ratio for lower middle income, applies only to the reference group for gender, which is males. So, for example, the odds ratio of 1.39 for lower middle income means that males in this income group are 39% more likely to earn a degree compared to males at the poverty level, holding all other variables constant. When we include the interaction term, the model adjusts to account for the combined effects of income and gender. This means that we're testing whether the relationship between income and degree attainment is different for males and females. The interaction term then tells us how the relationship between income and degree attainment changes for females compared to males. Now, the female-only odds ratio of 1.412, this represents the effect of being female on degree attainment compared to males, but only within the reference group for income, which is the poverty level. So what this means is females at the poverty level are 1.42 times more likely, or 41.2% more likely, same thing, to earn a degree compared to males in poverty, holding all other variables constant. So what we have here is our intercept, and then we have males across each of the income levels, so compared to the poverty level, and then we have females compared to males at the poverty level, and then the rest of the interaction, which is females at each of the other income levels. So you can pause this and read the interpretation of these results. It can really help in interpreting to graph the odds ratios, and you're graphing them against your reference points, your reference categories. And you can see from this that males, the income has a substantial and progressively greater effect on degree attainment, as shown by the odds ratios for the different income levels, whereas for females, the gender main effect, 1.41, reflects that females start with a significant advantage at the poverty level, and that advantage remains largely unchanged at the higher income levels. You can pause this and read how to interpret these results. Now, I just want to show you one more thing. Suppose you want to do the same analysis, but for only people who fit a certain category, like only people who applied for financial aid. You would put that in the filter, and let's say, yes, they applied for financial aid. So this will now do the same analyses, but it will only include people who applied for financial aid. And for this cohort, that's when they were first entering in 11-12. And when you run it, it's the same analyses, but now it's only including those people. And if there aren't enough people in one of the categories, it won't run it. You might have to collapse some categories. But let's see. Yeah, this runs. And so these are the results for the people who entered in 11-12 and applied for financial aid.